and contrast the two methods for determining whether we reject the null hypothesis or fail to reject the null hypothesis. So the two methods we have are either the critical value method or the p-value method. So suppose we have some test statistic that's on a normal or t distribution, that is, we're dealing with either a proportion or a sample mean for our purposes, and let's say our test statistic ends up here. Now of course it could end up on the left tail, either way, but let's call this x our test statistic. So the test statistic, those values are going to be on the x-axis, or what we would think of as the x-axis in a normal math class. Okay, so we've got some test statistic here. Now the critical value is some other value on the x-axis, say here. Now if that's my critical value, my test statistic has gone past the critical value into one of the tails. So that tells me to reject the null hypothesis. On the other hand, if we're doing the p-value method, the p-value is the area beyond your test statistic into the tail. And what you compare that with is the significance level, which is the area beyond your critical value. And so, I don't know if you can tell with my shading, but the blue area beyond my test statistic is less than the area beyond my critical value, which is the significance level. So you would reject the null hypothesis because your p-value is less than the significance level. So let me summarize this another way. It's helpful for me to think of these things and how they relate to each other by visualizing a square, only because there's four things that we have to consider. The first is the test statistic. Call that the test stat. The next thing is the p-value. Over here we have the critical value. And here we have the significance level. Now, the way these things work together is, in the critical value method, we are comparing. And in the p-value method, we compare these guys. So let me say that again. The critical value method, we compare test statistic to the critical value. In the p-value method, we compare the p-value to the significance level. Now, the way we get each of these things is that the critical value comes from the significance level. So let me say, when I write it this way, this comes from this. And then we have the same relationship over here with the test statistic and the p-value. The p-value, this comes from this. So the p-value comes from the test statistic, and the critical value comes from the significance level. So if we were to go the p-value method route, for example, we get our test statistic, and notice over here I say the p-value comes from the test statistic. The p-value is the area into the tail beyond our test statistic. So we look that up on the table, or we can use a spreadsheet with the normal distribution or the t-distribution function. And that'll give us our p-value, our area into the tail. And then the p-value method we compare to the significance level. And so that's usually given to us in the problem, and it's usually something like alpha equals 0.05 is the most common one, but it could be 0.01 or 0.1, something like that. And now we know that if the p-value is less than the significance level, you reject H null, the null hypothesis. And otherwise, you fail to reject the null hypothesis. Now, if we were to go the critical value method route, so now we're up here, we've got our test statistic. Now to figure out the critical value, you get that from the significance level. And the significance level, of course, is given. So let's say it's 0.05. So you look up 0.05 on, say, the normal distribution table, if we're talking about a mean, if we're talking about a proportion, you look that up on the normal table. And if we're talking about a mean, you look it up on the t-distribution table, or again, use a spreadsheet. And then you get the z-score or the t-score that corresponds with that significance level. Once you have that critical value from the significance level, now you compare that to the test statistic. And if the test statistic is further into the tail, than the critical value, then you reject H null. So notice in both cases, whether you're doing the p-value or the critical value method, you're going to, in my example here, you're going to reject the null hypothesis. Okay, then the only other caveat to all this is the idea of a two-tailed test. So if it's a two-tailed test, and you're going the critical value method, two-tail first says divide your significance level by 2. Or if it's the p-value method, and you're going to get the p-value from your test statistic, the p-value method for a two-tailed test says multiply the p-value by 2 before comparing it to the significance level. So the critical value method, you divide by 2, and the p-value method, you multiply the p-value by 2. Okay, I hope that helps a little bit. You might have to study this to kind of figure out what's going on here, but give it some time, ask some questions, and hopefully that will help.